All right, howdy, morning.
Morning.
Morning. We are going into day 3 of IFR. Kind of review or looking over what we saw is going to do today. It's going to be system failures. So kind of continuing off of the going or instrument failures, going over the instruments yesterday. ATC columns and like loss procedures. So loss procedures or loss column procedures is going to be a big part of instrument. Some DPEs, that's like the make or break for their check ride. Like if you can't answer the loss column procedure, then no, sorry, you're out of luck. So we'll go into that whenever this TV gets pulled away. Or we could just watch Tom Cruise M1, Mission Impossible.
I'm down. Yeah, do we get movie days?
Um,
Every Friday, I heard.
every Friday. We can watch air disasters every Friday.
Okay.
We can learn from the mistakes of
That's-
others.
Can't wait to go fly after watching that. That's
Yeah.
not.
That's like my grandpa does that. He'll watch air disasters and then he'll call me like, Chad, did you see that one episode? This one plane that crashed? Oh, go have a good flight. Like, thanks. Appreciate it.
That's funny. Okay, so first thing we're gonna lead into is what you all should be familiar with from private pilot is the DECIDE model. Basically just ADM, right? Aeronautical decision making. How do we take problems head on and deal with them? DECIDE model stands for D, detect the problem, determine that an action is necessary. You can't fix a problem that you don't know exists. So that's why it's an important instrument for us to always keep our scan going, looking at our instruments. Knowing how they work and what they should be indicating. So if they're not indicating what they should be, we might know there's a problem. Likewise, the engine instruments, those are pretty straightforward. We have an engine instrument page and those may be indicating incorrectly by showing yellow or red. So we have to be able to detect the problems first before we can do anything about it. E, estimate the significance of the action. Think it should say estimate the significance of the problem. So how severe is that problem that you've detected? Is it something that requires land as soon as practicable or land as soon as possible? Those are two ASAP acronyms that we hear in aviation. Sometimes something's not a big issue, right? If we, I don't know, just say our cabin light goes out and we're flying at night. Do we need the cabin light? No, does it make your life easier sometimes with being able to see in the cockpit? Yeah. Does that mean you have to declare an emergency and land as soon as possible? Is that part of the required equipment? No, right? So it's a minor significance of that problem. Now, if you're in IMC and your G3X goes out and you lose all your engine monitoring gauges, that's a little bit of a problem, because now you don't know if something's wrong with your engine, so. It's all about how it affects your the safety of flight, if you can continue or not. C, choosing a desirable outcome. So, this one's kind of funny, but obviously. We hope that everything's gonna be okay, we hope that we can land, we hope that we don't have to declare an emergency. So, but choosing the outcome and putting it in your head is, sort of like. Talking it into existence, like, all right. I want to land this plane safely, or I want to get back to this airport, for, this happens. That will sort of speak it into existence and, get you thinking about what needs to be done to be able to have the outcome happen. I identify actions needed in order to achieve the option. Achieve the chosen option. So pretty straightforward, what do you need to do to fix the problem? Is it a checklist? Is it maybe help from ATC, you request assistance? Flying the plane a certain way, to sort of deal with the problem if it's not an emergency. But what do you need to do? What are the actions you need to do to fix that? D, do the necessary actions, so follow that checklist, do whatever you need to do to fix the problem. And then E, evaluate the effects of the action, so. Either it works or it doesn't work, or maybe partly works. So you need to be able to evaluate, did the actions I just took fix the problem? Did it make it worse? Do I need to try a different method? At this point, once you do the evaluation of the effects of the action, that's when you can potentially have to go through the decide checklist again and be like, okay, that didn't work, so what's the problem still? And just start from the top. Any questions on that?
How often does that acronym get asked to be used in check ride?
Probably in flight 0. Okay, let me rephrase that. Emergencies do happen anytime on check rides. Are you gonna be asked about it in the ground? I haven't heard of anybody being asked about it. I would say it's more of one of those subconscious things that happen, right? So we're not gonna be like, all right. There's a problem, D, decide checklist, D, determine the problem, like, you're not gonna do that. But it's like, all right, a lane light's on, you notice it, that's detecting it, what are you gonna do about it? Cycle it, like, you're going through the decide checklist subconsciously every time you fly and something happens, so. But continuing off of that, emergency response, so. Always, aviate, navigate, communicate. The first and main responsibility of you is to fly the plane. Always fly the plane, even if you're an IMC, fly the plane. It's more important than troubleshooting problems and communicating with ATC or navigating. If you don't fly the plane, and you lose control, what's the point of trying to solve the problem at that point? So always fly the plane. Use all available resources. Talk to ATC, right? They're there to help you, and they will help you if you're attend to your needs, if you're in an emergency. Ask for assistance. Use your co-pilot in the cockpit, right? Maybe you won't be with an instructor, but maybe you're with a friend, and that friend may not have any aviation experience, but could they help you in some way? Yeah, they could, maybe look to see if they see the ground. If you're an IMC, they can read the checklist off for you. They can turn a switch on for you, like, utilize all the resources. And then follow emergency checklist. So we have our checklist that has most of the main emergencies on it. There's a lot more that could happen that's in the POH. You're obviously in a time critical situation, not gonna flip through the POH and try to find where you need to go. But with that being said, I scanned all the pages, the emergency procedure pages in the POH and made my own little like 3-ring sort of checklist, and I tabbed like, all right, electrical failures right here. Flat tire right here. So that's something you could do. But going off the checklist, where we have checklists, but you want to develop that flow. Electrical failure, engine fire, things like that, develop your flow and then go through it and then verify with the checklist. Smoke and fire. If you see smoke, don't assume you have Cheech and Chong sitting in the back or Jonathan. Assume it's a fire. On the ground, if you start the engine, fall and you see smoke, follow the fire during start checklist. That one, I believe, I don't know if they put it on the new checklist, but it's in the POH. Pretty much you're securing the engine, cutting off the fuel flow and egressing out of the plane and using that fire extinguisher. In flight, that's gonna be one of the flows we remember and verify with the checklist. But if you lose, or if you have a fire in flight, what are you gonna lose?
Your engine, lose your engine.
Are you gonna try to restart?
No.
No, so at this point, you're either hoping there's an airport right there, or you're doing off-field landing. You wanna land as soon as, immediately. Electrical fire, so this one will be in the POH as well, but you may not know exactly where the source of the fire is, but you'll want to turn off the master switch. Having an electrical fire means that those smoke and fumes will be more likely to be right in the cockpit. But there's gonna be a checklist for that in the POH. And then engine fire, yeah, so like I said, you want to remove fuel source by cutting off mixture, which we don't have, and fuel tanks. Perform an emergency descent to increase airspeed and create an incombustible mixture, so lean mixture. So cutting off that fuel flow and then emergency descent. All right, we're gonna watch a video. Movie time.
There is no room for error. Without power, the pilots have only one chance at landing. If they miss or overshoot the runway, the results could be catastrophic.
Minimum RAT speed is 140 knots, maximum speed for gravity gear extension 200 knots.
I'm not lowering the gear until the last minute, okay?
Okay.
The crew struggles to lose height and speed for landing.
Roger, Elijah, 6 nautical miles.
As they approach the runway, their speed increases dangerously. Too fast, and they can roll off the end of the runway.
Lower the gear.
Hold on. Speed is about 200. All right. I stabilize the speed. Can you give me a landing speed, please?
No engine, no flaps. Ideal approach speed is 170 knots. We're too fast.
Yes. The runway is very long.
Captain Pichet performs a difficult series of swerving maneuvers to slow the plane down for landing.
Plane was almost on a 45-degree angle. I thought it was just gonna flip over and just nosedive straight down.
The plane was circling around the island to slow down. So then we saw land and then we saw water. And when I saw water again, it really struck me that, you know, our chance for survival had maybe was gone.
The runway is long.
Yeah, sure, but at the end is a 400-foot cliff. If we don't stop in enough time, we're toast. We're dead.
The crew lines up the giant Airbus for the final approach.
Landing gear down and locked. 3 green. No flaps. Only the emergency brakes. No spoilers, no reverse thrust. 4,000 feet, 195 knots. 3,000 feet, 197 knots. 2,000 feet, 200 knots.
Alert the cabin.
Cabin crew, 1 minute to landing. Vertical speed at 3,000 feet per minute. We're going way too fast. And the speed's increasing, 203 knots now. It's way too fast.
But even if the crew can get the Airbus on the runway, they face a further problem. Without engines, the normal procedures for braking are severely restricted. For Flight 236, the danger is far from over.
Oh, everybody, I need you to brace.
The Airbus lands hard at high speed.
The tires have blown.
Captain Bichet tries to hold the nose down. After bursting 8 tires, the plane finally stops in the middle of the runway.
Um, The acting always makes it very hard to think of it as a serious situation. I don't know why too, but people were just like cringy back then. But anyway,
That's not bad.
I'll get behind that.
The stats didn't make sense either, because they said at 200 knots they'd overthrow the runway, and then they didn't even use half of it, according to them.
yeah, I was thinking the same thing. Okay, but the purpose of that is to show how they, I guess, use the decide model. Maybe not consciously out loud, but they identify the problem, right? The problem was that they lost their engines. They estimated the severity of the situation, right? It was pretty serious. They couldn't do a go around. If they overshot it, like that was it. They chose the desired outcome, which was they obviously wanted to land safely. And then they are going to identify actions needed, so they needed to slow down for one, right? They were fast, they needed to lose altitude. And then they needed touchdown in the right spot and brake in time. And then they did, right? So they tried to slow down by doing the S turns. They put out the landing gear, which probably in the end slowed them down, more than if they didn't put the landing gear down. Creating that drag. And then it worked, they landed, and yeah, they evaluated the situation. So that's an example of subconsciously using that decide model. Now we're going to talk about a few different problems. This is probably gonna, I think there's a few different situations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's like 10 different sort of scenarios. I'll just read through them and then we can talk about it. So engine issues, let's just say the engine is running rough, or you even have a partial power loss, so you're losing like some RPMs. You want to prepare as if an engine failure is imminent, rough running or partial power loss. Carb ice, the Venturi effect of a carburetor creates low temperatures that can create carb ice even when outside air temperature is nowhere near freezing. When carb ice is suspected, apply carb heat immediately. If the engine runs rougher and then improves, the carb ice was likely the cause. So what is carb ice?
That's when you have warmer, humid air going through the Venturi tube carburetor, and in that area of low pressure, it gets really cold. So it gets down to like 32, 33 degrees.
And then what happens when that ice builds up? What is it? What is it causing? What is it restricting?
It's restricting air and fuel flow, and it blocks up. If it gets really bad, it could block your throttle, and then your engine just dies.
Cool.
I've had carb ice a few times.
No big deal. Exactly. Okay, so let's talk a little bit about slaying. Let's just say you are at the run up, or you're taxiing, or you start up, you're on the ground, and you start that engine, and those RPMs are kind of going up and down by, a couple hundred, maybe 100 RPMs. And you're sitting there and it seems like it's kind of like oscillating, like going back and forth. That could be an issue with the engine, but what could it also be? What's something you should think about and take into account?
Wind.
Wind, right? That wind, maybe where we're sitting on the runway in the direction we're facing, maybe that wind is coming from the side or even coming from behind at that point. That hits the propeller in sort of a weird way and could cause those RPMs to feel as if it's running rough. So don't be alarmed right away if you have not necessarily a rougher feeling engine, but an engine that's sort of oscillating with the RPMs.
Sorry, quick question, is that pretty apparent in just the slings, or does that happen with, is it the propeller? Like what's,
I've
'cause I never really noticed that.
I've never noticed it in Cessnas. I've only noticed it in slings. It's not a performance thing, like it's not an issue, it's just the fact that like
it
you're
just happens.
sitting static on the ground, stagnant on the ground.
Yeah,
If that wind is hitting the propeller a certain way, you'll hear it and you'll notice it.
You could mistake it for an issue as well.
You could, yeah, so that's why it's
Yeah.
important, once you get going and you're facing into the wind, that run up is functioning or is performing properly, because that's really going to show you, is this plane safe to fly? What about on takeoff? What should our RPMs be?
Oh, above 5,000.
Yeah, I would say
like
5,000 to 5,200, maybe 5,300. But if it's like anything less than 5,000, if it's like 4,700 on takeoff, you might want to think about avoiding that takeoff. That's not what the RPM should be. It should be about a little bit above 5,000. Okay, continuing off of the rough running or partial power loss. Another reason could be fuel starvation. As the fuel tank runs dry, the engine may run rough momentarily before failure. Fast action to switch tanks or apply the fuel boost pump may avoid power loss. We have two pumps, we have main and aux, and our fuel selector is either on left, right, or off. We don't have both like in a Cessna. So if you are running low on fuel, the engine will shut off right away. If you are at the run up or you're sitting idle and you have aux pump off, you turn off main pump. Once that pump goes off, the engine will be off in seconds. So if you do run out of fuel, it might be trying to, suck up whatever remaining fuel there is, but it will run rough and it'll shut off pretty immediately. Likewise, if pumps fail. Pumps fail, you wouldn't even really feel the roughness, it would just shut off. Another reason could be magneto failure. We don't have magnetos, but a failing magneto is a common cause of rough running engine. Magnetos can be cycled in flight to determine if one has failed. In Cessnas, when you do magneto checks, so you're gonna have, it's gonna say, what is it, left, right, both, and then off. When you're doing your run up, you're gonna turn the key to right, and you're gonna look at the, what is it, the RPMs?
Yeah,
And then bring it back to both, and then when you go to left, look at the RPMs back to both. You're essentially just checking to make sure that the magneto will run properly if you are only on one. You'll notice, I believe, a little power drop, but then it should go back to normal.
Kind of like how we check the lanes.
Yeah. So yeah, lanes are our magnetos, I guess. No, I don't even want to say that. Lanes are a very unique thing. We don't have magnetos. So that's why if we turn the propeller, it won't start. But
I
lanes.
thought it was crazy when I first saw that, I was like,
I know,
oh.
somebody at the flight school next door apparently years ago,
Yeah, Whitney told me about that, I
yeah,
think.
it's pretty gnarly,
At
but
CFA?
yeah,
Really?
yeah. I don't know how many years ago, but it was a thing, so.
When people forget the mags all the time, when I was working as a line boy at the place, you wouldn't believe how many times I go in there and check before pulling the planks, I pull by prop. And you go in there and both mags are on, keys are in, or keys are out and both mags are still on, or one mag still on, like.
See, that's
Like,
crazy.
dude, you almost killed me, you took the keys out and there's like one or two mags still on.
Whenever I go fly Cessnas, I
Oh.
won't even like, I won't pull by the prop, can't,
I did for like, yeah,
stressed out. But we have lanes, so. Lanes, essentially what they are is, you flew yesterday, right?
yeah, I was
so we
actually
have-
gonna ask you what the lines are.
So we have two lane switches with a light. Having those lanes, and you can see this in the POH in the very back, I believe in my system PowerPoint, if you went all the way through it. It has a little chart from the POH in the back.
I didn't go through yet.
Okay, but the lanes control certain things in, within our engine. So our ECU, our engine control unit, is like the brain of our engine management system. So the ECU is going to control our 2 fuel pumps, our 8 spark plugs, and our 8 fuel injectors. You could sort of put the lanes as like a component of the ECU, but essentially they're just sensors. They're little computer modules that sort of control and oversee certain components of the engine, and they let us know when something's wrong. So a really good way, if I could think of it, is when you see a lane light on, think of it as like your check engine light on in your car.
Yeah, because I think when I was doing the run up, it's, you're checking the lanes, because you shut one off and you lose your engine instruments, shut one off
Yep.
and you lose other sort of indicators or instruments.
And those instruments is that chart in the POH.
Okay.
Yeah, what do we do if our check engine light's on, unless we're a mechanic, what do we do?
Report it,
Well, look,
depends on the situation.
is there something wrong with it? How do we know if something's actually wrong with it? What do we do? Where do we take it?
To the shop,
Okay, and what do they do?
check it,
By
code reading.
the ODD2 sensor, right? I think that's what it's called. Right, you could go to AutoZone for that, you could go to O'Reilly's, you just plug it in. As long as that check engine light's on, you plug it in, it'll read the code and show it's wrong. So what we have is FADEC. Have you heard of FADEC?
No.
Anybody heard of FADEC, or could tell me what it stands for?
I feel like I've heard that.
Like FAD.
FADEC. Anybody going once, going twice?
I've noticed that.
Have you heard of it?
I've heard of it, but I don't remember what it is.
So it's gonna be it's gonna be similar to the ODD2 sensor, but it's full authority digital engine control. We can only access that when the lane lights are on. If the lane lights are not on, we can't see FADEC and we can't see what's wrong. But if the lane light is on, we can look at FADEC, full authority digital engine control. And it's essentially reading the code and telling us what's wrong.
Is that already built into the plane, or is that?
You can check it in the plane.
So if you have a lane light on, you can check FADEC?
Yeah.
You can hit, I believe it's just home, it'll bring up a little like dialog box at the bottom and it should say FADEC.
Cool.
And then we
Or if
click,
you're on the engine instruments, click menu, and then FADEC pops up and you can click that and it pulls out.
exactly. But what we're doing when we turn off those lanes during the run up is we're making sure that the engine can run. We have two for redundancy, right? We're making sure the engine can run on one lane switch
Okay.
if needed. If one fails, will the engine still run?
Does it have extra, cause these are fuel injected, does it have kinda like how, you know, Cessnas have the two mags, the two magnetos, is it like two sets of spark plugs?
So we
Sort of
have
thing?
two per cylinder, two spark
Okay.
plugs per cylinder, two fuel injectors per cylinder. 4 cylinders total, 8 spark plugs, 8 fuel injectors.
So same kind of thing, like one lane for one set,
Well, that's the thing is we don't know, the ECU is telling those lanes to control whatever, we don't ever know how many
Really?
they're controlling. One lane could be controlling everything, it could just be split evenly, it might be kind of offset, but we don't know exactly what it's controlling, the ECU is what does that.
Kellen said that when you cycle the lanes, that's how you check the redundancy of like the spark plugs and but you don't know if they control it individually. It's like, what does that mean then? 'Cause he was
It
saying
means
like,
we don't know which lane is assigned what spark plugs, we don't know which lane is assigned what fuel injectors. We just know that the ECU decides that for us.
but we know that like when we are checking it in the run up, that's how we check like the redundancy
Yes.
of like the, okay.
Yes,
oh, okay, that makes more sense.
because if we shut off one lane and we see some issues with the engine, maybe that rise or drop more than 250 RPMs. That means something is wrong with one of with the lane or the spark plugs or the fuel injectors and whatnot, so.
Yeah.
Good.
That's good.
Internal engine failures, like stuck valve, etc. Internal damage to the engine may cause a partial power loss. Total engine failure may be imminent. So this could be a vast amount of things, maybe the air intake is blocked, or maybe there's some sort of butterfly valve not opening up and letting air in or out. Maybe the fuel injector isn't putting the correct amount of fuel. It can be anything mechanical within the internal parts of the engine that's not working right, and that could cause power loss, so.
If you have one spark plug fail, will the entire engine fail?
No, I don't think so. You would just get that lane light.
Got it.
Yeah, there's one of them that I did a maintenance flight on was having a problem where I believe lane A kept coming up. Maybe it was lane B, I don't remember. But the FADEC was showing ignition coil or cylinder 3 and 4 ignition coil fault or something like that, right? So how many ignition coils do we have? 8 ignition coils. Not spark plugs, not fuel injectors. One per cylinder,
So 4 total.
4 total. So if we lose one, that means ignition isn't happening in one of these cylinders.
Which means we lose a fourth of our power.
We will lose partial power. Yep, so. Overheating, so this is gonna be something approaching the summer months that is gonna be a thing that we have to pay attention to. Some overheating can be resolved in flight by increasing airspeed. But overheating is a dangerous condition that should be monitored closely. So on hot days, right, we might see our oil temperature or coolant temperature rising. If we're on the ground doing the run up, how do we fix that?
Increase RPM face into the wind.
Facing the wind, at idle, have it a little higher than 2000. 2000 is typically what we idle at, we could have it a little higher. Facing the wind. What about on the climb?
Just
Pitch down.
Pitch down, yep, decrease that angle of attack. Climb at a higher airspeed. What is our SOP for max temperature we could fly in?
It's 104.
Yeah, it's like 104, 105 Fahrenheit, which I think is like 40 Celsius. I've seen it the past few days at 33, 34, so it's getting close.
Yeah.
There will be days that you don't fly because it's too hot. So
It was hot yesterday.
it was very hot yesterday, yeah.
What's your personal minimum again? 95?
If it's at 35, I start to think about, where I'm going, what type of flight I'm doing, stuff like that. Once it starts hitting 37, 38, because even at 33 degrees, you could see overheating, right?
Mhm.
So it doesn't need to be 40 for things to overheat. What's another reason you could see let's just say it's a cold day. What's another reason you could see the oil temperature increasing?
You have either low coolant pressure or just low on coolant.
Oil.
Oh,
Oil temperature is high. Why? But it's 10 degrees Celsius out. Why is oil temperature high?
You have too little oil, or the oil's not pumping
Yeah.
through.
Yeah, so you were right, but oil. We're talking about oil.
it's still early, okay.
Yeah, so our oil temperature could be high because we don't have enough oil, we could have a leak, or we just didn't have enough. But what happens to our pressure, oil pressure? If we don't have a lot of oil,
It'll start to drop.
it'll start to drop. So those are two things we want to look at, and those are two things in the POH that you could look at. Cylinder head temperature and airspeed, so. How is our engine cooled? What are the different ways?
Air, coolant, oil, and
Yeah, air and liquid cooled, air coolant, oil. For cylinder heads, how are those cooled?
cylinder heads are the coolant, wow. Correct me if I'm wrong, but it's coolant for cylinder heads, and for inside it's oil. Not within the chamber, but
Yeah, the internal would be oil. But if it's a hot day and our coolant's getting hot, is components of our engine gonna cool as well? No, probably not. Probably gonna get pretty hot. So flying at high power settings and low airspeeds can lead to excessive high cylinder head temperatures. Avoid prolonged climbs at VX or VY, particularly on hot days. VX is 65 knots, VY is 72. Low oil pressure, we already talked about that, but causes decreased lubrication, increased friction, and can lead to overheating. Rising oil temperature is a sign of imminent engine failure. So if we don't have oil, that engine can and will fail eventually. Low oil pressure can lead to catastrophic failure. Low oil level could cause low oil pressure by starving the oil pump. Low oil pressure will decrease lubrication and engine failure will occur. Total engine failure. So fuel starvation is one of the most common causes of an engine failure. Every time you switch fuel tanks, try to have both pumps on and look for an emergency landing spot before. Because if you are on the right tank and you switch it to the left, and that left tank is dry, the engine will start and shut off. Also make sure it's in the full position, so make sure it's all the way to the left or all the way to the right. For us to turn the fuel selector off, you have to pull the little knob and then turn the little handle to the off position. Don't forget to switch tanks. We're pretty lucky that our G3X is set to usually an hour unless morons change it, but every hour we'll get a little pop-up reminder to switch fuel tanks. Try to just keep it balanced. That'll also help with our CG and everything. Carb ice, we already talked about that, but that can lead to total engine failure if not corrected. Catastrophic internal engine failure. So total engine failure can be caused less commonly by total failure of internal components. That's less likely with us because we have so much maintenance done. We have 100 hours, we get 50 hours done, so. Yeah, fuel starvation, while I'm on it, I want to reiterate this to you two, but bring it up to you. So forward slips, right? You're not gonna use much of that in instrument flying,
Yeah,
at all.
did some yesterday.
Perfect, so you know what's important
Keep the tank selected to the high wing.
to the high wing. So if we're going
Yeah,
to,
it's a scary realization.
so if we're going to aileron to the left and give that right rudder, which is gonna be the high wing, which one?
Right tank.
Right tank, yep, so we
Kind
need to
of-
have that,
Easy way to remember, she was telling me, is like you're stepping on the tank.
yes, yep,
'Cause that's something I'm also adjusting to, is having to switch tanks.
yeah. Well, like I said,
You know.
you'll have a reminder that pops up.
I
every
did,
now and then, so.
see it when I was flying yesterday, which was nice.
Yeah,
I mean, it'll be fine, it's just an adjustment.
yeah, that's a minor one. While we're on top of engines, I want to, just as a reminder for you guys, and bear with me. When describing our engine, there's an acronym we can use. So a DP is like, all right, talk about our engine. There's an acronym called R Tango 4. And that's gonna stand for Rotax 912 IS. So that's our engine. Horizontally opposed. For those who should know this, tell me what's next.
They're naturally aspirated.
Air/liquid cooled,
Oh,
which is air, oil, and coolant. And naturally aspirated. Which means what?
it's no forced air induction.
Cool. G,
Gear reduction.
gear reduction, what's that ratio?
2.43 to 1.
Oh,
Oil dry sump.
dry sump force lubrication. And D4.
4-stroke, 4-cylinder.
So this is like a basic way to describe our engine. If somebody asks, tell us
Is it
about our engine.
accurate if we got 100 horsepower?
I mean, when I tell people, I say, yeah, it's roughly like 100 horsepower, but I think it's like 98.5 to be more exact. I don't know how much the 1.5 horsepower, how much that makes a difference, but technically I think it's like 98.5.
So for the gear reduction, because I'm actually curious about that one. So it's 3.43 times. So that if the engine's rotating at 2.43, then the ratio is the device spinning at 1.
Yes.
Cool.
Yeah, so what is the propeller attached to? What exactly in the engine is spinning?
Crankshaft.
Crankshaft, right? That crankshaft is gonna be spinning however much it's spinning. If our propeller spun equally, right? If it was a 1-to-1 ratio, what are we at risk of with the propeller?
And flying
Flying
off.
off.
It flying off, braking, overspinning. So that's why we have that gear reduction box to give it that ratio. For every 2.43 rotations of the crankshaft, the propeller is spinning once.
Jeez, that's crazy. So the crankshaft is spinning like,
That's why RPM is so
Insane.
high compared to like.
and that's basically like a reduction from what that crankshaft is actually spinning at.
Yeah,
That's crazy.
it is crazy.
So camshaft spinning the propeller and the crankshaft is the one taking all the speed,
Crankshaft is spinning the propeller.
Mm-hmm.
and it's the one taking all the speed.
What do you mean?
It's the one that's taking the 2.43.
Yes.
Okay.
Yeah, like if you go and fly a Cessna, you're taxiing and idling at like 800-900 RPMs, and we 1,000 maybe, and we idle at 2,000, and our cruise is 5,000. A Cessna, might be what, 2,300, 2,400.
400.
So
So for the the gear again, so it's basically the way it works is the crankshaft spins at 2.43, just ratio wise, and the prop spins at 1. Right, okay.
Yep. So when describing the engine, that's how you would describe it. You could get more into the nitty gritty and be like, okay, this will be in the POH, our max continuous RPM. Max RPM for 5 minutes, what's our horsepower, stuff like that.
Okay,
But basically speaking,
that's the
this is
basic.
engine. Electrical issues. Do you? You guys have already gone through this. You're just like the basic PPL knowledge, so you know, you're in here for the instrument, but I need to tend to everybody's needs, so I'm gonna talk about the electrical really quick, and then we'll go into some of these issues. So,
Great review, so go into it.
you approve, sir? Cool.
Hey man, I'm here for the ride.
You here for the ride?
Oh yeah. I'm here for the qualifications. Yeah, you have your main bus memorized.
Pretty much.
I'm gonna have to do that then.
Alright, Core, whatever you do, I do.
Oh yeah, watch this. It's flipping the damn thing. And there's probably more on there, but that's like the basics.
When you get tested on the batteries information, they probably only want you to give a few answers, right?
POH.
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 Alrighty, so. Our electrical system, this is how I've drawn it out on every check ride. Our electrical system, we have 2 internal generators. Generator A, generator B. Essentially. If you look here, I'll have you come over here. If you guys want to come over here, you can. I just want to like point out where everything is at. I brought this down, by the way.
Thank you. Were you the one that helped unload it?
I mean, I was the one that literally like drove up to Torrance, put it in my truck, drove down the highway, brought it here, unloaded it, put it in here, labeled everything, plugged everything in, yeah. The internal generator is gonna be here in the back. So that little black cylinder sort of thing.
Oh.
Um,
It's connected to our crankshaft, yeah?
Yep, which is connected to the crankshaft and run all the way through here,
Is this the gear reduction happening right here?
yes.
And this one? So the
Yep.
crankshaft's spinning
Right
here, gear reduction prop.
Yeah.
See where it says gearbox?
Nice!
So do both generators have the 24 starters?
Stators.
Stators.
Yes. So for right here, we have our generator, right, or two internal. We're gonna
So
have this,
they're both in that
yeah,
housing?
we're gonna have these things called stators. Have you heard of those?
Yeah.
Do you know what it is? Can you describe it?
Isn't that sort of like the magnets?
Coils.
Oh,
So we have 24 of them, 24 stators, right? They're gonna be in here. What they are is they're, I think what is it, iron or magnets wrapped in copper wiring.
yeah.
And then on the crankshaft, we're gonna have a single magnet. That magnet and that crankshaft's gonna be in between.
Okay.
As the crankshaft spins, that relationship between the single magnet spinning in between all of these turns magnetic energy, or I guess electromagnetic energy to mechanical energy.
Yeah.
And then once it gets spinning, it's like a continuous keep spinning.
Got it. So
Um,
that's kind of the difference between the generator, like an onboard generator versus an alternator.
Yes.
Because an alternator is connected to a belt, which would drive it, and then
Yes, and you'll see, that word used interchangeably throughout the POH and throughout.
Great.
I've always said two internal generators, so. And we'll get into the starter system eventually, that's in the slide I sent you, and I think I have made it animated. But essentially, when we turn the key, there's a connection that closes, from the battery to the starter motor. The gears in the starter motor start spinning, which starts spinning the crankshaft, which then gets it going.
okay.
So 24 stators within the two internal generators. Both generator A and B are both creating alternating current. We have a rectifier regulator, sort of two components into one. So a rectifier, I believe, is what converts the power from alternating current to direct current. Because we want a more stable, current going to our equipment. And then the regulator is what sort of like holds and releases that power as needed.
Both
Got it.
rectifies and regulates.
Yes. And there's gonna be one here and one here,
Cool.
and they're both labeled, so. That's that. From there, the direct current from generator A is gonna go to the ECU, engine control unit, which is the brain, the core of the engine. There's lane A and lane B. But the ECU is gonna control the two fuel pumps, 8 fuel injectors, 8 spark plugs. 2 per cylinder. So I believe these spark plugs. So we have, spark plugs should plug in here, 1, 2, 3, 4, so 2 per cylinder. And then we have our fuel injectors right here, 2 per cylinder, and then there should be more plugged in down here. Or sorry, here's 2 for one cylinder, here's 2 for the other cylinder,
Got it.
You'll see that on
And then
both sides.
Spark plug.
and then spark plug.
Cool.
So 2 per cylinder. And then our fuel pumps are going to be, sorry, right here, main and aux. And that starter I was telling you about
Yeah.
is gonna be there.
Right, fuel pumps are normally like hanging right here-ish.
Yeah. Yeah, they're a little closer to the engine. On this side, generator B, same thing, alternating current, passes through the rectifier regulator, turns it to direct current, that goes to the batteries. What's the voltage of our battery?
12 volt.
We rock,
might be
paper,
wrong.
scissors.
Well, I don't.
So
I'm not
it's a
answering
12
anymore.
volt, it's a 12 volt battery, but you'll see sometimes 14 volts, and that's because it's able to hold those 2 extra volts to charge.
Got it. And that's why sometimes you see like alternators or generators having a different voltage than the battery.
So it's a
Like
12
alternator's
volt
like
battery, 14 volts, because of that, it keeps that charge.
Okay.
From the battery, it passes to the main bus. The main bus then sends power to things like avionics, autopilot, trim, flaps, lights, radio.
And that's where we're gonna have all the fuses. Oh, right, circuit breakers.
Yes. Cool.
Cool.
So this is our electrical system. This is how I would explain it on a check ride. And then we could go into, which I think we're about to do, but we could go into the See, right here, they use the word alternator, yeah,
Correct, yes.
anywho. Yeah, so this is how I draw the electrical system.
So where do the, so the A and B, those are the generators?
Yes.
Okay.
You wouldn't draw any of the failures into your electrical system?
Not at the start, I would wait until they bring it up.
These are the lanes?
Yeah, this is the laning maybe. If you wanna, lanes are confusing topics, so this is
Yeah, I'll,
also an appropriate way to draw it,
Yeah.
so.
Would you not include your ECU backup?
Only when they talk about failures.
Got it.
Don't overcomplicate it, so. If I ask you, all right, describe the electrical system, you just described it. I didn't ask you to start talking about failure. They're gonna ask you, but don't dig yourself a hole. Don't go any more in detail than you need to. So. Cool. So
Cool.
now we'll get into some of the failures.
is the generator shooting off 14 the entire time?
Yes, because of the charge. So,
So 14 to the ECU, 14 to the battery.
I believe so.
So I remember when I first came here, Jacob Bailey was talking about how like it would shoot off a certain amount, and the rectifier regulator would change it to a different amount, and then I remember one time I was like asking about it, and everyone was like, "What are you talking?"
Yeah, it's kind of hard to find that information.
Yeah, it doesn't really say.
Let's go and take a 10-minute break, by the way.
Yeah.
Wait, so the battery confirmed 14 volts, right?
So it's a 12-volt battery
But it can hold up to 14.
because of, so keep charging.
You should watch the systems video that Sling has on their YouTube.
Yes.
That's
Oh, they have one,
Yeah, let me see if I can find it and send it to
yeah,
you.
or it's just on their, it's just on their
can you
YouTube.
just start?
It's hard, I've
It's a
always
pain in
had
the
a,
ass to find.
yeah,
It's like
I've been having a hard time finding
really hard to find.
a lot of things, like for some reason, the resources page in Discord just disappeared for me.
That might just be like your settings and the way it's set up. Like if you go to it. So I know there's a way you can just accidentally take shit away.
Yeah, but like and it won't even,
Server guide. No. Browse channels. Go to browse channels and then you can click and choose what you want and not want. Like I don't have some stuff.
yeah, I mean, they're all clicks.
I have no idea.
Yeah, it's
yeah, I don't know why this video is always so dang hard to find.
Let me see if I can find it as well.
Feel like they might have it posted somewhere in the PowerPoint. Rotax 912, now it's a short. Hi, guys. Hi, guys. Wayne here from Sling Pilot Academy. We're going to talk to you about why you should start your airline pilot career with Sling Pilot Academy. We're going to talk about the pilot shortage, what's involved in becoming a commercial pilot, the training required. We're going to talk about what you need to do to get your 1500 onto a regional airline, the Skywest pilot. Can you find it?
Pretty sure.
Is it an hour and a half long?
Yeah, I'll send it to you.
Okay, perfect.
Thank you.
How do you send YouTube videos?
Don't ask me, I couldn't even find it.
I don't know how to send it.
There's a share button.
To buttons and
Ah,
share.
shit. Oopsie. See, it's like different from like sharing pornos and shit. I know how to do that. Yeah, watch this. I watched it like twice and it like actually helped me a lot with my system. It's a long
Nice,
time.
thank
though.
you.
It's like pain in the
Nice.
butt.
That's-
Pain in the butt. I'd be down to rewatch a little bit of it. I wanna like dial in how the crankshaft and like the stators. Cause they used to pretty
wanna
word.
stay later? But
Uh,
are you back at house later today? What are you?
Yeah, I'm gonna go back, make food, and then I'm gonna go fly and hit the gym. But before I go fly, I'm gonna just throw some stuff up, like where I'm screwed on.
What time are you flying?
1:30.
Okay, yeah, I guess I'm at 1, so. Oh, yeah. I'm gonna go back, so I'm hoping my iPad case gets there in time. Bring that.
Did your schedule for next week right come out?
Like so.
Okay, let me go into,
Yeah, man.
I'll just start it right now. So here's what I drew. This is what those stators look like. Magnets wrapped in copper wire. Surrounds a signal magnet attached to the crankshaft. As the crankshaft spins, the signal magnet in the middle of the stators also spins, which then generates power.
Is this in the PowerPoint you sent me?
Yes.
Nice.
So rectifier is a device that converts oscillating two directional alternating currents to a single directional current, directional direct current. Regulator is any electrical device that maintains voltage of a power source within an acceptable limit. Rectifier regulators and the sling are located on both sides of the fuse box, which I showed you. So the EMS, ignition control, fuel injection, fault detection, generator management. And then different components, we have sensors, actuators, different wiring harnesses, and then that ECU, which is the brain. ECU controls 2 fuel pumps. This is wrong, I apologize. 8 fuel injectors and 8 spark plugs. For engine control unit, consists of 2 modules, lane A and B. During normal operation, both lanes are engaged on for redundancy. When the engine is controlled by lane A, lane B ensures that the engine operates and maintains after failure. The ECU automatically selects a lane to control the engine. The lane lights pretty much just communicate with us when something is wrong or some sort of abnormal reading. FADEC, like we talked about, is where you can go and see what that fault is. It'll only show when the lane light is lit. Here's lane A, pretty much 2 spark plugs per cylinder, 2 fuel injectors per cylinder. But it can control it in any combination. We don't necessarily know what it is.
Got it. So that's basically like the ECU is just telling the lanes,
Yeah.
dividing it up,
Yep.
and then it just knows that it's doing it safe.
Yep. We have one main battery, which is a 12-volt battery. Battery provides power to the air. Jesus Christ, dude, why are you doing this? Charges 2 instrument backup batteries. First backup battery is located in the Garmin G5, so our smaller one. It has about an 8-hour battery life and fully charged. During normal operation, the aircraft's main battery is always charging the G5 battery. Second is for the G3X, bless you. Acts like the G5 battery backup. We have a switch called EFIS backup. The battery allows the EFIS to run even if the aircraft's main battery goes out. EFIS backup battery is always charged through the main battery. So here's sort of our electrical bus. We have our battery, which is going to go to our main bus. Lights, ELT, which ELT has its own battery, transponder, trim, flaps. EFIS 2, which will go power, that switch will turn on the G5. Avionics will turn on the GTM 650. Battery also goes to autopilot, and then EFIS 1 is to the G3X.
Our G5 also has a battery, yeah?
Yes, it has like an 8-hour battery life.
Which one did you say was the ECU backup battery?
Um,
The main battery charges a secondary battery.
oh, that was the EFIS backup, yeah. That's just for the G3X.
Okay.
Starter motor, I'll just show this. So we have our battery, we turn the key, it completes the connection, sends power to the starter motor, which turns some gears, turns the crankshaft, which spins that single magnet. That then creates power. If you open this up on PowerPoint, it'll actually be a motion. This is Google Slides, so it's not doing it. It goes through a regulator, which
Too
then,
broke for PowerPoint.
huh?
Too broke for.
Oh, okay, well, then you're gonna be stuck, it's like janky. Sends power back to the battery. We won't talk about the ignition system yet.
Yeah, please no.
Well, let's talk about different failures. So if we have a generator A failure, generator B is reprioritized to run the engine because that's most important, right? With that being said, if generator A fails, generator B is now going to be doing this, which means that there's no direct current going back to the battery, so the battery is not being charged. So eventually, give or take 30 minutes, we're going to lose all of these things because we've lost the battery. How can we elongate the life of the battery?
Shut down certain electronics.
Yeah, if we don't need
Simple
lights,
stuff.
turn it down, autopilot don't use, comms, try to not to be a yapper on comms.
And quick question, I always assumed that generator B went to generator A without regulating.
That might be the case.
Okay.
I'm not really sure.
Got it.
Yeah. I would assume so. But yeah, I'm not for sure.
I won't change my slides then.
We will see a drop in the main bus voltage, plus minus 12.5 volt. Okay, yeah, I actually have that in my slide, so yeah, it's gonna look like this. Like that, pretty much. If generator B fails, generator A will keep sending power to the ECU to keep the engine going, but once again, we're not sending any power to the battery. So eventually, the battery will die, give or take 30 minutes, depending on if we can shed the load. We'll also notice that drop in the volts. So here's sort of the diagram of that. We lose generator B, generator A is still sending power to keep the engine running. We'll lose that battery. Now, worst case scenario, we have a dual generator failure. If both generators fail, no power is available for the ECU and the battery. This is when ECU backup switch comes into play. It'll send power directly from the battery to the ECU. So now what we're doing is we have this. So if we lose generator A and generator B, we're not getting power here, we're not getting power here. Our engine will probably shut off because, it's not getting any power. But we have this thing called ECU backup. When we turn that on, it's going to connect the circuit, send power from the battery, whatever is remaining, to the ECU to keep the engine running. So that's why when you see in our engine failure checklist, it's going to have you turn that ECU backup switch on along with some other things, and then you crank the key. And that's to send power from the battery to the engine. Keep in mind that battery will only last, give or take 30 minutes, probably less. So you'll want to land as soon as possible. Otherwise, you will have no engine, no avionics, trim, flaps, lights, all that stuff will be gone as well.
Yeah.
This is a very last resort sort of thing, but, or worst case scenario, but you are, going to need to land as soon as possible.
Quick question.
Yes.
In this system, there is a total of two batteries, right?
In where?
The system here,
Um,
you have the EFIS battery and the main battery, right?
yeah, I guess you could say that, but you don't need to throw that in.
Yeah,
EFIS backup is just the G3X having this backup battery.
I just remember being asked by Aaron how many batteries are in this link system.
So there'll
The
be,
answer is 3.
there'll be the main battery.
That was 4.
Technically, I would say it's 4. Main battery, the EFIS 1 battery, so the G3X backup, the G5 backup, ELT.
Got it. Oh, yeah, because ELT.
And the ELT battery is apparently located beneath the right seat.
The ELT battery is its own separate battery, right?
Yes.
That isn't connected to any other system.
Nope. So technically 4 batteries. Main battery, G3X backup, or the EFIS backup, the G5 backup, and then the ELT. Cool? Cool. Initial indication of a generator failure, your RPMs and everything look good, but these amps will start to go negative. We want them to be at 0. If the amps are at 0, that means we're using as much power as is being produced. If it's negative, that means now we're using more power than being produced. Vice versa, if they're positive, that means we're using less power that's being produced. We want it at 0, but this will be the first indication of a generator failure. Next, the amps will continue to go down, and now we'll see that volts 1 is starting to go down. That'll be right at plus or minus 12.5. So now it's going into the yellow, 12.4. RPM is still good though.
Is this going to correlate, if you can go back to the slide, that as a generator A failure and generator B for working?
Um,
I thought you couldn't know.
yeah, you
Okay.
won't know.
So don't correlate the two.
No.
Okay, got it.
Yeah, so in the POH, I'm not gonna read through this, but there's different EFIS, you can do this on your own. Different EFIS system failure procedures. And then right here is that, table of lane A, or the failure of lane A or B, what are the resultant sensors that are lost as well.
Yeah.
So go through this on your own. I'm just gonna briefly look through this to make sure. If lane A or B does come on, all you do one at a time. If only one is on, cycle it off, turn it back on. And then that should resolve the issue. If it doesn't go off, then that might mean there's an issue.
If both are on, don't cycle.
I wouldn't know, because now you don't know which one is just a
Running.
sensor issue and which one's actually not working.
Yeah.
They could both be a sensor issue, but what if one's not? Now you're playing Russian roulette, so,
Shut your engine off.
yeah.
On
No.
startup?
No, just
No,
if
like
you're
in the
flying and you
Just
have
like
both lanes, if you're on the ground, who gives a
Yeah,
shit, but
because
if you're
most of
flying,
the time it does that when the plane hasn't been up in the air in like a day.
yeah. Shed the workload and expect the battery to have half an hour, probably less. I could send these slides to everybody as well.
That wasn't part of the one you sent us yesterday, right?
No, that was my own,
Oh,
yeah.
I like it though.
That was the diagram I just showed, that was the one I made, so.
Okay, cool.
Other electrical issues, popping fuses and circuit breakers. If the circuit breakers are popping, there may be an electrical short in an overload condition. Shed electrical load by turning off non-critical items and attempt to reset the breakers by pushing them in. If they keep failing and keep popping out, don't keep pushing it in, because that means there's something wrong and you're now overloading the system. There's a short circuit and that can lead to an electrical fire. Electrical short / fire, turn off master switch entirely. Remember, some airplanes need electricity for flaps. Prepare for a flapless immediate landing. So just sort of a heads up for you, Chad, when you are doing your engine failure and engine fire procedures, the checklist is going to have you turn off your master as one of the last things. Why do we wait to turn off the master? Because once you turn that off, you now can't use your flaps.
Right.
So we want to use flaps as needed, ensure that we're making the landing spot, and then turn off the master. Night consideration, airplane lights such as landing lights may be unavailable, and radios are necessary to control pilot controlled lighting at non-tower airports. Carrying a portable VHF transceiver may be useful as a backup when making night flights, such as one of the handheld radios. I don't have one, they're very expensive.
I've heard you can make them.
Huh?
I've heard you can make them.
I'm sure you can.
I'm pretty sure one of the students here did.
Got a sporties one.
Oh, sick. Yeah, those could be nice, so. Instrument failures, so we already talked about the pedostatic system yesterday, we're not gonna go into that, we talked about the vacuum system. Hydraulic issues, so brakes, if hydraulic brakes fail, pilots can use aerodynamic braking to partially compensate. So let's just say we come in hot and we land and we start to apply brakes and they're not working.
You need to go around and reset.
Yeah, there's a few different things you should ask yourself. One, are you prepared and in a position to be able to use up a bunch of runway? How much runway do you have? What's your airspeed? Stuff like that. So personally, what I would do is I would go around, circle back around, and I would come in and do a short field landing. So I do my short field landings at 65 knots. You can even go as low as 60 knots. Come in, land slow as possible, and then aerodynamic braking. What does that consist of? How do we do that?
Ailerons full aft, and I've heard.
Well, you might not want to do full aft right away because you could.
Yeah, I've heard a debate of flaps area as well. I've heard.
Retract the flaps.
Yeah, a lot of people say you and don't.
Well, don't, because it puts wear and tear on the tires. Do if you're actually in that situation, because who gives a shit if you wear the tires a little bit, right? You need to stop. So aerodynamic braking, retract the flaps. What's that going to do? What do flaps help us do?
Create lift.
They create lift. They also create drag, but they create lift. So when we retract the flaps, we're now losing that lift, and it's going to put more weight on the landing wheels. More friction is being created, and it'll help slow us down.
That's it for aerodynamic braking, is just pulling the flaps up.
Pretty much, yeah.
It's like a short field landing, you know, full flaps and that's great.
Yeah, they don't want us doing that in training because it does put wear and tear on the tires, but an actual short field landing, you would do that, right? As long as you're not doing it every single day. But in
You're not supposed to pull the flaps up when you actually do your short field.
I mean, yes, you are. But here in a training environment, I was told that it'll put wear on the tires.
What about on the check ride?
That's fine. That's once, you know. But if you have 5 flights a day, every single student is just fucking cratering landings and doing aerodynamic braking and putting wear on the tires, they're eventually gonna go, so.
That makes sense.
Do you actually have a similar question for the learning Steve? Why don't we as wing students practice like simulated engine out upon takeoff? For example, I've heard Franco's brakes pretty good.
So, I do it at Ramona Dirt Patch. I don't know, can't speak for other instructors, but I'll have my students do an engine fire, be like, oh, okay, look that way, boom, pull the power, do an engine fire or failure. Like, all right, show me you can land this plane. And I'll let them get until like the grass is like tickling the bottom of the wheels. Like, I have them show me that we can do the landing, tell them to go around, and on the climb out, I'll fail the engine again and say, what are you doing? Where are you landing?
That's a
So,
very real thing to practice.
Mhm. So I can't speak for other instructors. If you had me as an instructor, we would have done that, but yeah.
Whitney actually talked about that yesterday.
Mhm.
Well,
Yeah.
getting low.
Well, if you have an engine failure on takeoff,
A lot of people talk about it, but it's never been, I've never had someone. have
That's
to
the
practice it.
most likely spot to do it.
yeah,
Or for it to happen, because if you, let's just say you're going on a cross country here to Vegas. And you're at the halfway point, I mean, unless there's like no oil and you fucked up on that end, like. The engine's been running fine for an hour or two already, so why is it gonna fail, right? You've already tested it, it's already been warmed up, why is it gonna fail? But on takeoff, you know, just started the plane maybe 15 minutes before. Can't really tell if there's something wrong, maybe something to run up you missed, on takeoff is when you would notice that. Landing gear, so we have a fixed tricycle. We don't have to worry about the retraction of the landing gear, but you probably wouldn't notice if you had a flat tire. Well, one, pre-flight, right? You should see if there's something wrong with the tire in the pre-flight. It most likely wouldn't pop mid-flight. But let's just say, hypothetical situation, you're coming in for landing, you somehow felt and realized your tire popped midair during flight, and you now have to land the plane. You just want to come down. Well, there's a checklist for it, but you want to touch down with the lowest possible airspeed at a tower airport where services can be available, and maybe you overfly the tower and they can let you know, hey, yeah, we do see a flat tire. And then most likely when you land, what's gonna happen if your left tire main is out?
You're going to have.
Yep, so be prepared to apply rudder, not too much, but just the right amount. Other failures, so let's just say we're flying along and you forgot to screw the cowling covers down, recheck the oil, you see that pop open right after takeoff. Let's just say right on the takeoff roll, what could you do? You just gave it full power and you see that open up.
Power idle brake apply
or
okay.
takeoff.
Now, what about if you 100 feet in the air?
Circle back to land.
Yeah, fly the plane, aviate, navigate, communicate, just, right, it's not detrimental, if that's open, it's open. That could be an issue,
I had my door open at 150 one time.
yeah. My, when I fly with my buddy, he, will be in the back seat and I'll be like with somebody in the front seat, he likes to open up the windows on Cessnas. Yeah, we departed John Wayne, which, you know, busy airport in a 182, so a lot more going on. It's a little more complicated of an airplane. And
Yeah.
on takeoff and talking to ATC, doing like departure procedures. And he decides to open up the window. And let's just say I was really pissed. We got to cruise altitude and that autopilot came on and I took care of business.
Chonkless.
Yeah, if the canopy opens, right, because we don't have doors, if the canopy, you realize it's unlocked, what do?
Well, fly. If you're on takeoff roll aboard, if you're taking off, fly the pattern, just fly the plane.
Yep, yep. You know, maybe once you're in the downwind and you're in like a sort of cruise flight, you can try to close that. It's actually really hard to open. If you're in cruise flight and you try to open it, there's a seal on it, so it's gonna be really hard. Like you could unlatch it and just like leave it, and it's not gonna open. Like there's like
Is that because of the pressure
suction, yeah, because of the pressure difference. So,
It's crazy.
yeah, all right, we have higher pressure inside the airplane than we do outside because of that airflow over the canopy. Where does high pressure want to go?
Too low.
Low, so that air is sucking out, which is why we see people fly out of airplanes when doors open up and whatnot. But it's pretty much just sucking that shut. So you really, like, if you open the canopy and you pull it, you're gonna hear like the whistling suction, and then eventually you could get it open.
even with the vents open, it still has that much suction. Cause
Mhm.
it's simulating pretty much like a.
I mean, think about the airflow vents compared to 100 knots outside the plane.
Mhm.
That's gonna be a very drastic difference in air velocity and pressure.
Yeah, yeah.
So, still gonna be higher pressure.
Mhm.
Doesn't matter if there's airflow. If you take this versus, right, you're gonna feel both of it, but if there's a surface there, which is creating lower pressure, it might lower the pressure in both, but the faster moving air is gonna be that lower pressure.
Mhm.
Think about like Bernoulli's principle, right? You have air flowing above the wing and below the wing, right?
Mhm.
But the air on top of the wing, because of that curvature, is gonna be flowing faster, therefore making it lower than the air on the bottom of the wing.
Yep.
There's still probably a decrease in pressure in that air underneath the wing, it's just higher than what's on top of that
Yeah.
fast moving air. Inoperative or runaway trim. It can be possible with us, especially because we have electrical trim, that button might get stuck and it might just keep going.
I had that one.
I've had it happen too.
I've had Aaron simulate it for me. I'm like, that's so hard to pull back.
It is, it's like you hold it, it just goes.
Mhm.
So one, be ready to correct for it and hold that pressure. Two, you would maybe avoid using the trim, but also checking the circuit breaker to see if that is popped out. Because maybe it got stuck, circuit breaker popped out, and you're trying to give it back and it's not working. Could be the circuit breaker. But just be ready to increase the control pressure. Cool, it's up 30 minutes. Everybody awake? Good?
Yep.
Okay.
Small nice break.
Yes. Pilot responsibilities and ATC responsibilities. So when communicating with each other, it's your responsibility to be able to understand, repeat back, and comply with what ATC is telling you. Especially with IFR clearances, which can be a little more complex and a little bit longer. Repeating back correctly eliminates any confusion, right? ATC gives you an instruction. You repeat it back. They let you know if it's correct or not. And this is so that you understand what you're being told and they understand that you understand what you're being told. So that's why repeating back the important information is very important. It also saves time repeating back correctly from not having to do back and forth of, no, that was wrong. This heading, this altitude. Because they're busy, you're busy. Yeah. Control responsibilities, they're pretty much to maintain aircraft separation for IFR, right? This is accomplished by providing IFR clearances to pilots. So we've talked about this before. What are some reasons why on a craft clearance they might give you climb and maintain 4,000, expect 6,000 in 10 minutes?
Faster moving traffic.
Fast moving traffic, right? There might be an aircraft, when you get to this point, there might be an aircraft flying over you at 5,000 feet, right? And this might be at the 5-minute point. So 10 minutes is over here, you're not clear of that traffic and you can climb up. Yeah. Communication frequencies, so FSS, flight service station. A pilot's first contact with ATC is usually through one of these, either by radio or telephone. They can provide pilot briefings, receive and process flight plans, relay ATC clearances, originate NOTAMs, and broadcast aviation weather. So a lot of different services they provide. Some facilities provide en route flight advisory services, or EFAS, take weather observations and advise the U.S. Customs and Immigration of international flights. So you're not necessarily going to be on with them the entire time, you know, flying your IFR flight plan. They're just sort of there to provide these supplemental sources before, maybe during the flight, but typically before.
Yeah, I was gonna ask, when do you typically use flight service station? I've never contacted one.
I have only done it, right here, telephone contact with flight service can be obtained by dialing 1-800-WX brief.
Oh, I've done that.
Yeah,
So
so that's like when I've really used it. I've never filed a
Okay.
flight plan with them. I've never gotten clearances.
I was gonna say, 'cause it's always confused me about like getting a clearance from them or getting
Yeah.
a flight plan from them. I've called WX Brief to get, briefings before, but
Yeah,
not, okay.
yeah, that's all I.
So like, it's like, it's there as a resource if you need it, but it's not something that you have to use if you basically filed online.
You don't
or
need
you
to use that to go fly IFR. Yeah.
It's just a resource.
Yep. ATC, so there's different multiple controllers in the tower that are involved in handling instrument flights. So obviously in our tower, we have somebody that's an overseer, right? Probably the tower manager or whatever. We have somebody, maybe two people running ground if it's busy, one or two people running the tower. Maybe we have somebody running our clearance delivery if it's really busy. There's various people that are working in the tower at one time. Where there's a dedicated clearance delivery position, that frequency is found in the chart supplement and on the instrument approach chart for the departure airport. Where there's no clearance delivery, the ground controller performs this function. At the busiest airports, pre-taxi clearance is required. The frequency for pre-taxi clearance to be found in chart supplement. So here, whenever we get IFR, or when you start doing approaches, we will pick up a VFR practice approach. So we're doing practice approaches in VFR conditions, not on an IFR flight plan. Flight following, VFR practice approaches, IFR clearances. We get all of those from ground. If they're too busy, I believe you had this on your face check with Aaron, they'll pass you off to clearance delivery. If they're busy. So ground's our typical go-to, clearance delivery if it's really busy. And then we'll go, after we get our clearance, we can request taxi, or if we're on clearance delivery and we get our clearance, we go back to ground and get our taxi instructions.
So when we're doing IFR practice here in actual flying, so you said it's on VFR flight following and VFR rules. Is it like, do you tell ground or whoever that's giving you your clearance that you're doing practice approaches and they let you practice the approaches just under VFR rules?
Yep. All right, Ethan, go ahead and contact ground for VFR practice approach.
VFR practice approach, Gillespie ground, sling 1232 alpha with a VFR request.
Slaying 1232 alpha, Gillespie ground, say request.
1232 alpha is Sierra Lima Golf 2 slant golf, picking up what practice approach?
ILS 24. Palomar.
ILS 24 for Montgomery?
Palomar.
For where?
Palomar.
For Palomar. Under VFR.
That's it. Don't even say that. VFR request. Your type of aircraft. So Sierra Lima Golf 2 slant golf. SLG 2 slant golf.
That's for all of our planes?
Yep. Requesting VFR practice approach. ILS 24 to Palomar. And that's it. And then they'll come back and they'll give you a craft clearance, which you copy. So yes, you need to specify you want a VFR request. They're going to tell you to say it. And then you want a VFR practice approach, whatever it may be.
Got it. And so with that, if you're asking for a practice approach, even another airport, they'll give it to you. So like you're saying Palomar, so
Yeah, so that's how you have to do it,
you
yeah.
want Palomar approach, ILS, blah blah blah.
Yeah,
They may give it to you.
yeah,
Maybe.
depending on weather, because you're requesting VFR.
Right.
Depending on controller.
So like if you go up here when it's not busy and you say you want a practice approach here, like they may give it to you.
I mean, they will give it to you, yeah. Like there's 95% of the time they'll give it to you. It's only major reasons they won't give it to you. Like your check ride, you're gonna do that. Your approaches face check, your final face check, you're gonna do that.
So it's not actually filing on IFR, it's
No.
VFR
No.
practice.
And that's why you specify, because if you just say, looking to pick up be careful using the word like pick up, because a lot of times people say pick up IFR. So if you say pick up the ILS 24 in the Palomar, they're gonna ask you, would you like to file IFR or VFR? That's why you just say requesting VFR
Be very
approach
specific about that.
ILS 24 into Palomar. Cool.
Cool.
All right, TRACON. TRACON is considered terminal facilities because they provide the link between departure airports and the en route structure of the MAS. Terminal airspace normally extends 30 nautical miles from the facility with a vertical extent of 10,000 feet. However, dimensions vary widely. Class Bravo and Class Charlie airspace dimensions are provided on aeronautical charts. At terminal radar facilities, the airport is divided into sectors, each with one or more controllers. Each sector is assigned a discrete radio frequency. So you've done flight following, Chad?
Yeah,
So it's the same thing. Down here, we're talking the SoCal approach and SoCal departure.
okay,
Imagine there's a big building, right? Big building, very dark rooms. Imagine these are little cubicles, right? They're in their own little cubby, looking at their own screen, they have their own radio. This controller might be on this frequency. As you fly along and you get to the edge of their airspace, they're then gonna pass you on to maybe a different frequency. As you go along, they might pass you on to a different frequency. Once you get to the edge of their airspace, pass you on, and then at this point, they might pass you on the tower. So it's the
Okay.
same thing with IFR as you do with VFR flight following. If we're flying here to Vegas IFR, you're gonna talk to different controllers once you get to the edge of their sector, their airspace. And
got
then
it.
eventually they'll pass you on the tower. So
Okay.
essentially, it'll go ground or clearance delivery, the tower, to approach / departure, to a different one, to a different one, to a different one, and then the tower, and then the ground. And that's like what a flight looks like and consists of. When you do your VFR practice approaches, depending on where you're doing it, they might pass you on to a different frequency. So if we go up to Palomar, our first frequency, our departure frequency will be one thing. But because Palomar crosses into a different sector, they'll give us to a different SoCal frequency and then eventually the tower.
And it's sort of just like a bigger version of VFR flight following because like SoCal approach and departure is a much bigger covered area.
You're
From
talking
one
to the
control.
same, if you flew from here to LA,
Yeah,
VFR versus IFR, you're talking on the same frequency.
okay,
So as VFR practice approach, you'll be on the same frequency as somebody on the IFR flight plan and
Okay.
vice versa.
because I've never talked to SoCal approach departures or anything. Like, when I was training, I was in Santa Paula. We never went south. We always went north.
Okay.
So I was always talking to like Magoo approach,
Magoo, yeah.
Santa Barbara.
Yeah, it's the same exact
Same kind of thing?
Same thing.
Okay, so SoCal approach and departures is just a larger area than, for example, like Magoo.
Yeah, because
But same idea basically.
Point Magoo approach is, for the Point Magoo air base, but it's the same exact thing.
So
It's
SoCal does like LA down to here.
Yeah.
Okay.
And then you'll have like LA Center scattered here and there, like when you go
Okay.
out east of Vegas, you might be on SoCal and then LA Center, and maybe back to SoCal.
Okay.
I don't know how the sectors are broken up, but it's the exact same way as if you fly on NorCal or Santa Barbara approach. Okay, so here's an example what I just talked about route, right? So you go tower to TRACON, then you might be on a center like LA Center, back TRACON, and then to tower your destination.
What's the
airport.
center? Just
That would be like SoCal or like LA Center.
it's
It's
just like
yeah.
another one of them, just named different.
Yeah. Tech, tower and route control. At many locations, instrument flights can be conducted entirely in terminal airspace. These tower and route control tech routes are generally for aircraft operating below 10,000 feet and can be found in the chart supplements. Pilots desire to use tech tower and route control should include that designation in the remarks section of the flight plan. So let's go ahead, maybe they give an example. No, they don't.
So what's even really the difference between tower and route control versus the regular frequencies you'd use?
Like with like the SoCal versus tower?
Yeah, so is tower and route control, is that instead of talking to approach or departures, you're basically just on towers? Is that what it is, or?
So,
I'm just a little confused, like what it actually,
so what we just talked about, tower and route control, right? Are you talking about this, well, like right here, this? Is that
yeah,
you're talking about?
what,
So that's a route.
okay,
This is a predetermined route that you will find in the chart supplements.
oh. Thought that was like. I don't know, different type of controlling agency you talk to.
No, so. In the chart supplements, you're gonna see this right here, this section. This is going to be the start of where all those predetermined routes are. So if you're in the terminal area, right? You can choose a route. So if I want to fly here to LA, there might be a predetermined route that I can
Oh,
follow.
is that kind of like when you're transitioning through the LAX Bravo, you can get like a VFR transition? Or like the coastal route or something?
No.
No?
Those are visual, those are like visual.
Oh, yeah, no, that's
eight,
VFR, okay.
VFR. This is an IFR predetermined route that you follow. And when you contact ground or clearance, they may give you one of these or you can request one of these. Make sense?
Got it.
ARTCC facilities are responsible for maintaining separation between IFR flights in the en route structure. Center space is divided into sectors in the same manner as terminal airspace. Additionally, most center airspace is divided by altitudes into high and low sectors. Each sector has a dedicated team of controllers and a selection of radio frequencies because each center has a network remote transmitter / receiver sites. All center frequencies can be found in chart supplements. So basically everything we've talked about, the TRACON, the centers, the ARTCC, these are all just different facilities. They're not towers at an airport. They're just random like warehouse office style buildings that have a bunch of controllers, like an assembly line sitting. And if you fly through the airspace, you'll talk to this person. As you go through the airspace, they'll pass you off to this person and so on. That's all these are. They just offer different IFR separation on
Different-
IFR
This
services.
is like the same thing as like the other ones.
Pretty much, yeah.
The practice area, that right now.
Everybody have this written down?
The
Yeah,
gist of it.
Um. And let me just sort of reiterate too, that I thought of like a better difference. So the difference between TRACON and the ARTCC Raycon is the terminal area. So when you, as we said, terminal is usually within 30 nautical miles of a facility. So Traycon is gonna be your approach and departure. So SoCal approach, SoCal departure. That is Traycon. ARTCC, that's gonna be the en route structure. So when you're more than 30 nautical miles away from a facility, you're gonna be on the center frequency. So that's why when you fly from here to Vegas, like in this picture right here, right, you depart Gillespie, you're on with Tower. Then for a while, you're gonna be on with Traycon, which is SoCal departure. Eventually, once you're in the middle of nowhere, you're gonna be on with an en route center, so that might be LA center.
Okay.
As you get closer to Vegas, you'll be back on with Traycon, which will be Vegas approach. And then back to Tower.
Okay.
So that's the biggest difference. They do the same things, it's just geographically, where are you?
Got
Are you
it.
within that 30 nautical miles of a facility, or are you outside of that?
It's like the same IFR services, but for just ones for, so the facilities are like. So Traycon's for terminal areas, like 30 nautical
Yes.
miles around the facility, but that facility is what, that's
Just that building
just that
with,
building?
with all those controllers in it, yeah.
Okay, so like, so for SoCal approach and departure, so they have just one building, or is it multiple for?
I don't know. I mean, there's a building,
Cause it's 30 nautical miles, but it seems like it seems like SoCal approach and departures has a much larger area than that.
yeah, so there's probably multiple buildings.
Oh,
They're just spread out, yeah, it's not like one building in San Diego that covers all the way up to, you know, Point Magoo, where that starts.
okay, got it. So it's like if SoCal approach, sorry, so they have their buildings, whatever, they have their airspace control, you get out of there, and then you're on with ARTCC,
Yeah,
something like that, and then in middle of nowhere, attack.
yeah. So you see in the picture how the en route center has a little bit bigger facility. That's because that's gonna be outside that terminal area, so they have to have that equipment to be able to communicate with you and see you a lot further out.
Okay. Where does ARTCC?
The en route center,
That's what,
yeah.
would that also have tech there?
So the tech is a route, that is,
Oh,
I don't know
oh.
why they have this here, a tech is a
Okay.
route. So it's an
Okay.
IFR route, not an IFR facility that you talk to.
Got it.
Yeah,
Can you restate the distances for tower takeoff and route?
I mean, Tower is just gonna be within the airspace.
Okay,
Traycon is gonna be within the terminal area, so 30 nautical miles. And then en route or the center is outside of that 30 nautical miles.
okay.
And yeah, the ARTCC is the Air Route Traffic Control Center. Air Route Traffic Control Center. And then Traycon is Terminal Radar Approach Center.
Traycon is terminal,
Terminal Radar Approach Center?
what's the ON stand for?
Huh?
What's the ON stand for?
Well, Terminal Radar Approach Control, maybe CON is just control.
Yeah,
Maybe they just want to make something better than just track.
yeah, I like Traycon better.
Terminal Radar Approach Center.
Terminal Radar Approach Control.
So it's Tower, Traycon, which is like approach, departure for SoCal. And then en route, so center or ARTCC,
Yep,
and then back to Traycon, back to Tower.
yep. And we're gonna call it for today because we're out of time, but tomorrow we'll go into identifying nav aids.
Is that lost comms?
It'll be going into lost comms, yeah.
Not all of Lost Columns, or
It's not all, I mean, that's a section of it, but,
it's pretty big.
I mean,
Why do they want you to know which of the areas you're in, like the airspace, the terminal area, and then is that? Because you're already gonna know it with the chart, so why would you have to memorize different things?
well, you don't necessarily need to memorize and be like, oh, I'm talking to center, I'm more than 30 nautical miles away, it's just how it's organized, right? Like, why is it important that you know you're talking to ground while on the ground? Well, that's just who you talk to when you're on the ground, right? Same thing with this, like, when you're within 30 nautical miles, that's just their capability. Their capabilities extend up to 30 nautical miles.
Got it.
And when you're outside of that, they pass you on.
I guess it's kind of good to know. I guess like going into the Lost Comm stuff is like knowing where you are and who you can
And I
possibly
agree
talk
with
to.
that, yeah.
So it's like, okay, well, I'm not supposed to have to talk to approach or departure, so you know, maybe I can get a hold of, you know, an air route traffic control center or something else.
Aren't you
Exactly.
always gonna be having like what's the ETA thing at the end of certain craft clearances?
I mean, you won't have it at the end of a craft clearance, but you'll have an ETA like if you filed a flight plan. Right, but that doesn't matter if you're in the middle of buttfuck nowhere and you are in IMC conditions and you can't see, you know, your hand in front of you if you stuck it out the airplane and you lose comms, right? If you lose comms, what else could you lose? Navigation, your G3X, right? So you assume that if you lose something, you're gonna lose more.
Yeah.
And knowing where you're at that's literally all IFR is you need to know where you're at, because if you don't, then that's usually how bad things happen.
Got it.
Uh. Cool,
Cool.
cool. All right.